React hooks. They work by using special hook functions within a component. In React, we can make simple components using functions, but most UI components need to change over time. They might need to update their data, react to events, or work with parts of the web page. Before React version 16.8, developers had to use classes to use certain features. But now, while you can still use classes, hooks usually make it easier to build components because you can use stateful logic without changing how your component is set up. React has many built-in hooks, and by the end of this video, you'll know the most important ones. If you're new here, don't forget to like and subscribe. If you're new to React, it's good to know why hooks were made in the first place. Before, the logic that kept track of changes in an app was tied to class-based components. This meant that you had to make a component to work with changing data. But in reality, this led to a tangled mess of components inside components. Previously, I used to not like React because sharing logic meant using tricky techniques like higher order components and render props. These made things more complicated compared to other frameworks, like Angular. But hooks changed everything. They give you access to React's basic features outside of components. When you use hooks, think of them as the building blocks of React that give you special powers that you can't get with regular JavaScript. Hooks are just functions that start with use because they tap into React's special abilities. Before you start using hooks, remember one important rule. Only use them at the top level of a functional component. They will not work inside regular JavaScript functions, nested loops, or anything like that. The only exception is when you're making your own custom hooks. useState is without a doubt the most important and the most frequently used hook. Import it in your React app and then type out useState. The purpose of useState is to handle reactive data. Any data that changes in the application is called state. When the state changes, React will then update the UI so that the latest changes are reflected to the end user. This hook takes an optional argument, which is the default state. We will set this to 0. This is a function that returns an array that contains two values that you can use within your component. They get returned in an array so that we can destructure them with JavaScript to assign the values to local variables that we can then name whatever we want. The first value is the reactive data or state. If we then reference that in the UI and its value changes later on, React will rebuild the UI to show the latest value. It will start with a value of 0, which is our default value of the hook. But how can we change its value in the future? We can do that with the second element in the array, which is a setter function. For example, we can listen to the onClick event for a button. When it is clicked, the setter function gets called to increment the count by 1. useEffect allows us to apply logic across all lifecycle methods within a unified function API. useEffect is a function that accepts a function that you create as its initial argument. React then executes your function or side effect once it has updated the DOM with the current render. This function runs anytime there's a change in the stateful data of the component. This means it activates once the component is initially mounted with the default value, and then again each time the state or count changes. Although you'll probably prefer more precise control over this behavior. For example, let's say we need to fetch data when the component first mounts. We then asynchronously update the state after the data is fetched. This process could lead to an endless loop because every fetch leads to a state update, which then triggers another fetch, and so on. To handle this, we use a second parameter to useEffect, which is an array of dependencies. If you put an empty array, it signifies that there are no dependencies, which means it will only run once when the component is first mounted. But in some cases, you might want to re-execute the function whenever certain stateful data changes. This is done by including the state in the dependencies array. React will then track that value, and anytime it changes, it will rerun this function. Lastly, another aspect of useEffect is to execute some cleanup code when the component is unmounted. To implement this, we return a function from our useEffect callback. React will then use this function for cleanup when the component is being removed. The useContext hook allows you to work with React's context API. This is a mechanism that allows you to share or scope values throughout the entire component tree. Let's say we have an object called theme that can be either dark or light. To share the current theme across multiple disconnecting components, we can create a context. One part of the application might be dark, so we use a context provider to scope the dark theme there. Another part of the application might be light, so we use a context provider to scope the light theme there. Now, any children component inside of it can inherit that value without needing to pass down the props to the children. This brings us to the useContext hook. It allows us to access or consume the current value from the context provider. This value may reside many levels higher in the component tree. Reading a parent value from useContext is a whole lot easier than passing props down through multiple multiple children. Now the theme changes from dark to light in the parent provider. The value here will be updated automatically. If you've ever used useContext in the past, you've likely used the consumer component. The useContext hook is pretty much just an easier replacement for the consumer. The useRef hook allows for the creation of a mutable object that will keep the same reference between renders. It can be used when you have a value that changes. It's like setState, but the difference is that it doesn't trigger a re-render when the value changes. For example, if we tried to build a counter button with useRef, we could reference the current count by calling count.current. That being said, when we click the button, the count would never change in the UI because useRef doesn't trigger a re-render like setState does. That can be useful when you need a mutable value, but a more common use case for useRef is to get HTML elements from the DOM. We could start by creating a null reference called BOOG button, then connect it to the raw HTML button using the ref attribute. From there, we can reference the HTML button in a function to call native DOM APIs like click in this example, which would programmatically click the button. The bottom line is that when you need to get an element from the DOM, useRef is the hook you're looking for. useReducer is similar to setState. It just goes about it in a different way, using the Redux pattern. Here's how it works. Instead of updating the state directly, you dispatch actions that go to a reducer function, and that reducer function determines how to compute the next state. Just like useState, useReducer returns an array of two values. The first value is the reactive state that you want to show in the UI. The second value is where things differentiate from useState. Instead of a function that updates the state, the function dispatches an action. An action is just an object that has a type, which can be any string, and an optional data payload. Dispatching an action when a button is clicked will trigger your reducer function. The reducer function is something that gets defined and gets passed as the argument to the useReducer hook. The function then takes the current state and the action's arguments and uses the two values to compute the next state, which is typically handled by a switch statement. In this example, if the action is increment, we add one. If it is decrement, we subtract one. The hook also takes the initial state as its second argument. Although this code is a bit more complex, it can help you out in the long run if you're planning to make a very large app. If you add more components to your app, it becomes increasingly more difficult to manage state reliably and predictably. The Redux pattern may help with that. The useMemo hook helps optimize computation costs for improved performance. Although you should keep in mind that we don't want to prematurely optimize performance, so think of this hook as an opt-in tool to deal with expensive computations that you know are hurting your performance. Let's say we have a counter again, but then we compute an additional property after that called expensive count, which requires some kind of expensive computation. Instead of recomputing on every single render, we can memoize the value. We write a function that returns the computed value, and as a second argument, we add the dependencies to determine when this computation should run. In this example, it would be whenever the count changes. That's great for memoizing return values, but other times, we may want to memoize an entire function. In that case, you're looking for the useCallback hook. When we define a function in a component, a new function object is created each time the component is re-rendered. Usually, this isn't a big deal for performance, but sometimes we may want to memoize the function. The most common use case for this is when you pass the same function down to multiple child components. By wrapping the function in useCallback, it will prevent unnecessary re-renders of the children because they are always using the same function object.